Hi everyone, I'm going to show you guys of how to find the center of mass of this diagram that I have here. So it looks, it's a sphere, right? It's a sphere, and the top is chopped off, and you can see the part that's in gray. So that's the chopped section. So we need to find the center of mass for that section, right? So, and they've given that the center of mass is h into 4a minus h over 4 into 3a minus h. So we'll have to prove this, right? And by the way, I'm really sorry if you guys hear any background noise. I'll get that fixed as soon as possible. I mentioned in my previous video too. So, yeah. So let's start the question. So I'm going to use the integration for this question because I find it easier to find the center of mass because this is pretty complex. It's not that easy, and it's from a further maths mechanics edXL textbook. It's one of the hardest questions in the textbook. So yeah. So what I'm going to do is, before starting the question, what if I break this? Okay, with the dashed line, I'm going to break this down from the center and from the top. Okay, so can you see if I take this as an arc? Can you see this arc? So if this arc was on an x and y coordinate graph, can you see if I draw another line from here, if this arc with this shaded region is rotated around the x-axis for 360 degrees, it will form this full shape, right? It will form the chopped section of the sphere, right? I hope you guys see it. I hope you guys understand it. If you guys have any doubts regarding that, please drop a comment. I'll explain it again. So what I'm going to do is I'm going to draw the coordinate, the x and y lines. So I can just do that. And then I could, so this is how I'm going to draw it. So the arc this way, like that. Can you see? So if I draw another line, like this, it's straight right here. So this is h, which you can see in the diagram. You can see h, right? Let me just erase that stuff so you guys see it. So that's h, and this is gonna be here, right? That's the radius, d. This is also a. So when this shaded region is rotated around the x-axis, you can find the volume, and then using the volume, we can find the center of mass using integration, which is easy. You can do this. Okay, but first, there's one thing you have to do here. We need an equation, right? For this arc, for this curve, it's like a curve, right? So we need an equation. So can you see it's part of a circle, right? It's part of a circle. So what's the general formula of a circle? So you can write x minus h squared plus y minus k squared equals r squared, right? So h comma k is the center and r is the radius, right? So in this case, what's your center? This is your center. And what is that point? A comma 0, right? The radius is a. So it's a comma 0, right? So when you put those into your equation, you have x minus a squared plus y squared equals e squared, right? I hope you all understood that. So then you can rewrite that as y squared equals a squared minus x minus a in brackets squared, right? Now let's find the volume. So volume equals to pi into the integration from 0 to h, right? Because that's shaded region, this coordinate is going to be h. 0 to h. 0 to h. So the general formula for the volume is fx squared dot dx. So fx squared is y squared, right? So we already have y squared. We can just directly put in that. So we have to integrate a squared minus x minus a squared dot dx. Okay, so let's integrate this. So we have pi into, so what's the integration of a squared? That's a squared x. A is a constant, right? Minus x minus a in brackets to the power 3 over 3. That's easy integration, right? So now let's put in our intervals 0 to h. So now we have pi into a squared h minus h minus a to the power 3 over 3 minus, now you substitute 0. So a squared into 0 is 0 minus a over, no, minus a to the power 3, yeah? Over 3, you can write it like that. So now, and now let's expand the brackets. So we have pi into, we keep pi outside, a squared h. Let me just give up some, like give some more space. A squared into h minus, so h minus a to the power 3. So you can expand this using binomial expansion, but I'm not going to do that because it takes time. I'm just going to like straight away write in the expansion. But if you guys need help with that, please drop a comment. I'll help you guys with that. So the expansion of h minus a in brackets to the power 3 over 3, and we have a minus in front, right? So that gives you h cubed over 3 plus a h squared minus a squared h plus a cube over 3. And here we have, so that's plus, so it's minus a to the power 3 over 3. So you can see this will cancel off, and this cancels off, right? So now we have pi into ah squared minus h to the power 3 over 2, which is your volume. So you found your volume now. Now we know the volume of that shaded region, right? Now let's go for the center of mass. So the formula for center of mass is x equals to pi over v, and interval 0 to h, it's going to be x into fx squared dot dx. So in this case, it's x into the term we had for y, right? Which is a squared minus x minus a squared dot d, right? So let's integrate that. So we have the integration of e squared into x, which is a squared over x squared over 2, right? Minus x minus the integration of x into x minus a squared dot dx, right? So how do you integrate that? So you can take a substitution of u equals x minus a. So you can write a equals, no, I'm sorry, x equals u plus a. And you can write du over dx equals 1. So du equals dx. So the integration of that is u plus a. X is u plus a into x minus a is u, which is u, but you have squared, right? So u squared dot du. So now you have to integrate u to the power 3 plus au squared dot du, right? So that's u to the power 4 over 4 plus a u to the power 3 over 3. Now let's put in our substitutions back. So we have x minus a to the power 4 over 4 plus a into x minus a to the power 3 over 3. So then our answer is, so we have pi over v, right, into a squared x squared over 2 minus x minus a to the power 4 over 4 minus a into x minus a to the power 3 over 3. I'm sorry guys, like I think you guys are hearing background noise at the moment. I'm really sorry about that. It's just whenever I make a video, there's always someone talking. So I'll get that resolved soon, all right? So apart from that, let's solve this question. We have more to solve in this. We just have to find this, and then we can find the center of mass. So we can leave pi over v aside. So a squared or into x squared over 2 minus. So I'm going to do the same thing now. So x minus a. Oh, wait a minute. Let's put in the substitutions. Let's put in the substitutions first. So h 0 to h, right? So we have pi over v into a squared h squared over 2 minus h minus a to the power of 4 over 4 minus a into h minus a to the power 3 over 3 minus, I was putting 0, so it's minus e to the power 4 over 4 minus a into minus a to the power 3 over 3, right? So we'll keep pi over v outside. So now we have a squared h squared over 2 minus h minus a to the power of 4 over 4 minus a into h minus a to the power 3 over 3 plus e to the power of 4. And yeah, it's minus a to the power 3 over 3, right? And let me just recheck everything. Oh, wait, this has to be a to the power of 4, right? Because it's minus a to the power of 3 into a. So it's minus a to the power of 4 over 3, right? Just like earlier, I'm not going to expand h minus a to the power of 4 and h minus a to the power of 3. You can use binomial expansion. If you guys have doubts with that, please drop a comment. I'll help you guys out with that. So I'm just going to, like, write down the expansion instead. So a squared into h squared over 2 minus. So h minus a to the power 4 over 4 is h to the power 4 over 4 plus a h to the power 3 plus, no, it's minus 6 over 4 a squared into h squared plus a to the power 3 into h minus a to the power 4 over 4. Okay, and minus a into h minus a to the power 3 gives you a h cubed over 3 plus a squared over h squared minus a cubed into h plus a to the power 4 over 3. And then finally you add your final a to the power 4 over 4 minus a to the power 4 over 3. So you can see that this cancels off with that, and this cancels off with that. What else can we cancel off? Anything you guys notice? Okay, we can cancel off. There it is. What else? What else can we cancel off? Oh, can you guys see? A squared into h squared plus a squared into h squared over 2 is 3 over 2 a squared h squared, right? So 3 over 2 a squared h squared minus 6 over 4 a squared h squared is 0, right? So 6 over 4 is 3 over 2, so that will cancel off. They will also cancel off. So now you end up with pi over v into, and now you have ah to the power 3 minus ah to the power 3 over 3 minus h to the power 4 over 4, right? So pi over v into ah to the power 3 minus ah to the power 3 over 3 is 2ah to the power 3 over 3 minus h to the power 4 over 4, right? So this is your center of mass from the origin. So center of mass equals to pi over v. So So remember, this is from the original, right? So 2a h to the power 3 or 3 minus h to the power 4 over 4 over. Now let's put in our volume. It's pi into. Pi's will cancel off. So what was the volume? It was ah squared minus h cubed over 3. Let me just recheck that. I think I'm right. Yep. So what can you do for the numerator and denominator? Let's multiply both by 12. So now you get 8 ah to the power 3 minus 3h to the power 4 over 12 ah squared minus 4h to the power 3. We can take h out, right? So we can take h cubed out in the numerator. So that is 8 ah minus 3. I'm sorry. 8a, just 8a minus 3h, right? Over, and you can take h squared in your base. So I'm going to take h squared out, and it's going to be 12a minus 4h, right? These cancel off, and you just end up with h. So your center of mass is h into 8a minus 3h over 12a minus 4h, right? But remember, this center of mass is from the origin, okay? So it's from the origin. And I forgot to mention that this center of mass is proven from the surface. So I'll just write in brackets, from the surface. Because you know the book, in the textbook, it's a long question, so I just didn't want to like fit that into the video. So that I just thought of putting in the answer straight away so I can prove it, because that's how the question was, but it had a big description, so I just removed that instead. So what the question said is to prove that it's this center of mass from the surface of yeah. So basically they chopped it off, so the shaded region is actually removed off. So what you have remaining is this, right? Like a was. So they're asking us to find the center of mass from that surface, all right? So we got the center of mass from the origin, but we need it from this line. So we need to subtract this with h, right? So it's h minus the center of mass from the origin, right? So it's h minus h into 8a minus 3h over 12a minus 4h. So let's get the common denominator. So we have 12h minus 4h minus h into 8a minus 3h over 12a minus 4h. So now you get 12ah squared minus 4h squared minus 8ah plus 3h squared over 12a minus 4h. So now you get 4a. Hold on a minute. I think I made a tiny mistake. This should be h. That's just 12a, alright? So it's 12ah here. So it's 4ah minus h squared over 12a minus 4h. So we can take h from the numerator out. You can take h out, and you can write a minus h, right? Oh, sorry, 4a. 4a minus h over, and from the denominator you can take out 4, and you can write 4 into 3a minus h, right? I'm thinking this was the answer. And yep, it is correct. So we got the answer, right? Wasn't that bad? Yeah, it's a big question. Yeah, so that's everything for this question. If you guys have any doubts, please drop a comment. I'll help you guys out. And if you guys like my video, leave a like and subscribe. Have a great day. Thank you so much.